Hey, what's up? This is gonna be another quick Geometry Nodes tip. And I'm not just coming up with random tips to share. I'm working with Geometry Nodes almost on a daily basis to get some stuff done. And recently I was working on a mesh. It was kind of an organic mesh, and part of it I needed to smooth it. And so I was like, there should be a smooth node that can actually take a mesh and smooth out the shape. And I'm not talking about the smooth shading node, because that's not what I mean. That's like, compared to what I'm talking about, that's like a joke. Smooth shading is just taking, it's not really changing anything of the mesh. It's just taking the faces and interpolating the normal along the face to make it look round instead of flat. And it's a nice trick to make something look smooth, but I actually need to make it smooth, for real. So I was in need of a node like that, and I think it's such a useful node that there will be a point in time where the Blender developers add this node to Geometry Nodes to actually allow you to smooth it up. But right now, there is no node like that. So I'm going to show you how to create one. And the way I found out about it was I was actually planning to figure out a way to do it with nodes. And then I failed with my original plan. But then in the process, I found out another way. And it actually works way better, probably. So yeah. Without further ado, I will show you how to smooth your mesh with Geometry Nodes. So here in Blender, let's start with an ugly mesh. And with ugly, I'm just gonna add a bunch of vertices here. I'm gonna move them around randomly to make it look the opposite of smooth, pretty much. Select one and do this like that. That looks pretty ugly. All right, so let's pretend you end up with something like this in Geometry Nodes and you want to smooth it out. Now, of course, there is a modifier that can do this, and this is what I'm looking for. But in Geometry Nodes, whoops, factor of 1. This is exactly what I want to try and do. And I believe, like, looking at the result of what my Geometry Node solution is, it's pretty much the same thing. So I'm really happy with this accidental thing. So let's look at Geometry Nodes and how to do this. Now, first of all, why would you want to do this in Geometry Nodes and not use the modifier? In Geometry Nodes, you have a lot more flexibility about, like, where you want to apply this smoothing effect in a modular way. Look, you could say maybe based on a proximity node, you could apply the smoothing effect, or there's so many possibilities. I'm not even aware of half the possibilities probably. But it's just way nicer to have a node that can do the smoothing instead of having to do it in a modifier. So that's why. Okay, so we have our Geometry Nodes set up right here. So I'll just quickly explain what my initial idea was. So I found this node that has information about the edges. And let me try to find it here. We have edge vertices. This was the node that I thought could be useful, and it actually is. But when I thought about smoothing, okay, what are you actually trying to do with smoothing? So I was trying to take, like, okay, what if we could make every edge the same length? Or, right now it's not smooth because the edges have all different lengths. So what if we could find a situation where every edge has the same length and kind of move from this position smoothly to a position where every edge is the same length? If you can do that in a controlled way, we might be able to smooth it. So that's what I was trying first. So I was trying to use this And you don't have the edge length here, but you can get it from the two vertices that make up the edge. So if you look at edit mode, these dots are the vertices and these lines are the edges. And this position 1 and 2, that's like the two vertices that make up the edge. So if you take the distance between these 2 points, then you have the length of the edge. And you can easily do that with vector math nodes by taking position 1 and position 2 and just taking the distance. There is a distance function that does that for you. And then you end up with, if we look at this from a viewer, and I have to plug in the geometry so that it knows what context it's in. We can see here the viewer value. These are the edge lengths. So that's very useful information to have. But then I ended up failing to do anything with it. So I was like, okay, for every edge we have this length. So what if we could move the vertices, like for this edge, this is way too long. It's longer than the average. And you can get, by the way, you can get the attribute statistic, you can get the average length of your, of all the edges with the mean. Mean is average. And the mean is 0.0739 something. That's the average. So for example, this edge here is longer than that. So what if we could just take these vertices and nudge them together to make this edge shorter? And of course, every vertex is usually part of multiple edges, so it will get nudged in different directions, but probably on average, it will end up being smooth. That was my idea, but I failed to do something with it because then I was like, okay, how do you nudge these vertices? That's probably using a set position. And if we plug that, not there, if we plug that in, let's plug it in here. The set position node works on this field and it works on a per vertex basis, but this works on edges. So I wasn't sure how that would connect. And we also have information about which vertex index it was. So my idea was to use a selection based kind of loop through every edge in some way and use the vertex index to select the correct vertex by comparing it with the actual index and then setting the position for each vertex like that. But that didn't work. That ended up not working because what I ended up doing was it was only applying it to the first vertex, I think, something like that. So that didn't work. But later, and then after that failed, I was a bit sad. But I was just doodling with the nodes and the noodles and everything, and somehow suddenly I had a smoothing effect, and now I understand why it works. But at the time it was just an accident, just a happy accident. So let me show you what I did. So instead of getting the length of the edge, I want to get the position of the edge. So what is the position of the edge? Well, the edge has, it's not a single position. It's, of course, it's like a whole edge. But I want to get the center of every edge. And you can simply do that by taking the average of the two vertices. I believe there is no mean or average. So we have to add them together using add. And then we scale it down by 0.5. It's annoying when it connects somewhere you don't want it. We scale it down by 0.5. And that gives you the length. That gives you the position of every edge. And now I'm using that to set the position of every vertex. Does that make sense? No. You take every vertex and you set it to the position of an edge, but which edge does it take? And I think now in hindsight, I think if we're working on this vertex with the set position, and you set it to the edge, it takes all connected edges and it takes the average of that. And that makes it smooth. So let's look at what happens. Look at that. We suddenly have a smooth mesh. Look at the difference. Simply by plugging in, like calculating the edge position by taking the average of the two vertices that make it up and setting the position to that. That's all it is. So we don't need this, we don't need this. This is all we do. We take our geometry and we set the position of every vertex to the edge of the position of every edge, which I'm not sure how it works behind the scenes, but I think what it does is it works on this vertex here. It takes all the edges that are connected, takes all these positions, the centers of these edges, and then it sets the position of that vertex to the average of that. And in the corner it's a bit different, because in the corner vertices they only have two edges, so it will move in that direction because it's getting pulled towards the connected edges. That's how you can see it. And if we turn it off, you can see this corner is being pulled towards the center. And that's all it is. And this smooths out your mesh really well. And currently we don't have loops in Goemetry Nodes. This is something that's will make some crazy possibilities possible, I think, when that gets added. But for now, if we want to make this even more smooth, we can just do it again. And there you go. And we can do it even a third time. And it gets really smooth. So if you go into the modifiers, we can turn it off and on. And that's what we're doing. We're really smoothing out this ugly mesh. Now, this is exactly the same as using, or almost exactly the same as using the smooth modifier. But I can quickly show you something that you can't do easily with the modifier, which is only smoothing the inside vertices and not smoothing the boundary. Let's say you want to keep the boundary the same. In this case, doesn't really make sense, but you want to keep the boundary where it is, and you only want to smooth the inside. Well, you can easily do that by creating a selection of your boundary vertices, which you can do using a mesh edge neighbors. This goes, again, it takes all the edges and it counts how many neighbor faces does it have. And all the interior edges have 2, but the boundary only has 1. So if we now compare this with, we compare an integer to 2, then 2, then we only get all the vertices that are connected to edges with 2 faces next to it. And if we use that as a selection, let's put that above, then you can see that the edge remains, or the boundary remains the same. Wait. Oh, it should be equal to 2. There we go. So now you can see, if we toggle this, the border remains exactly the same, but the inside gets smoothed. Beautiful. And it also works if you go into edit mode and let's select some faces, select some random faces and delete them. Ooh, that's nasty. Let's clean that up a little bit. Okay, now you have a very ugly edge here. This doesn't make sense, but you can you can now smooth out only the inside, and the borders will get recognized using this selection here, where it has 2 neighbors and it doesn't get applied to that. Yeah, only the interior has 2 neighbors. So yeah, that's really cool. There's one more thing I would like to do, and that's now we're just only able to iterate using these 3 set positions. We have 3 iterations going on, but it would be nice to smoothly transition between the original mesh and the smooth mesh, and that's very easy to do. I'm thinking, should we make a group node out of this, or first make that transition? I think we can do the transition first. So we need another set position, because we want to set the position to either the current position of the smooth result or the original position. So how do we get back to the original position from here? If we plug in a position, that doesn't work. That's doing nothing. Because this position in this context is the position of the smooth result. What we want is we want to capture the position of the original geometry. So in order to do that, we need to capture an attribute and capture it at this point where it's still the original. And then we want to capture the position, so I'm just going to duplicate this. What we want to capture is a vector. Plug that in. Now we're capturing the position at this point, and we can use that to set the position. And now it's back to the original. If we turn it on and off, it's the same thing. Doesn't do anything. And if you plug this one in and we turn it on, it's smooth. So we want to be able to transition between this position and this position. And there's a dirty trick you can do by using a mix RGB. There's no such thing for vertices, so we have to plug a blue socket into a yellow socket, which in some cases it's fine. But you have to be aware that colors sometimes work slightly different than vectors. But this is a quick trick of doing it. So now we have a slider going from the original to the smooth version. And that's pretty cool. And if you don't wanna plug a blue into a yellow, we can do it with actual vector mat as well. What we want to do is we want to scale. Let me quickly show this. We want to scale between the original and the smooth position. And the way we want to scale is like, when we want to have a smooth result, this should be 0, this should be 1. And when we have the original, this should be 1, this should be 0. So you want to have a value. And this is the amount of original. This is the amount of smooth. So this wouldn't work, but we need a math node, and we want to subtract. We kind of want to inverse this on the domain 0 to 1. So we want to take 1 and we want to subtract this value and plug it in here, and then combine them using addition. And this pretty much just takes a weighted average between the two, between these two positions, between the smooth position and the original position. So we plug that in, we have a way to do the same thing. But this takes like 4 nodes instead of 1. But this is a little bit cleaner, I think. Okay, so this is how to smooth your mesh using Goemetry Nodes. And we can make a nice group out of this. I don't want to include this selection, so I'm going to separate that. But the rest here we need. Yeah, so all of this contributes to smoothing. So I want to Control G and make a group out of this. And I want to organize this using my Arrange plugin. I don't want to center them. I'm going to put this margin to 60. And that organizes everything neatly. I can remove this. And I can also plug in the selection into the last set position. This actually shouldn't matter, but just for consistency. And I want to, instead of having this value, I want to pull that out of the node or pull that out of the group. So I want to have a group input over here. And I want to create this value. And I can remove this too. And let's organize this. This should be factor. And we can make it the second one. And by default, it should be 0.5. And it should have a range from 0 to 1. That makes sense. You could go beyond it, but it doesn't really make sense. All right. Looks good. And now we can go out of that and organize everything here. And now we have a node group. We can call it smooth. And now we have a way to take our geometry and smooth it. And if we don't select anything, we'll select everything. And we can smooth our geometry using this node. And we can plug in a selection to only select the inside or anything we want. We can plug in a factor based on some kind of proximity or something cool. And yeah, that's our smooth node. And I am definitely going to use this trick. There will probably, I won't be surprised if there will be an actual dedicated smooth node that's way more fancy than this. But before that happens, I'm gonna definitely use this way of smoothing things. And you can, if you want a more smooth result, this is pretty smooth to me. But if you need more smoothness, you can add more of these set positions and just iterate again and again and again, and pretty much do the same thing. But yeah, that's how I accidentally found out a way to smooth my mesh. I hope it helps. And yeah, see you in the next one.